Okay, example of 3. You'll notice if you keep looking through the page, they get uglier as we go down, right? Example 3 is kind of a place you're going to get to in these problems as they get more ugly. Every one of these problems is going to get to this spot where you got an x on both sides, a number on both sides for the most part. The last couple we had an x on one side and numbers on both, but now x on both sides. But notice there's no parentheses. If I'm comparing sides of this, the left-hand side is 3x minus 4. The right-hand side is 8 minus x. There's no parentheses. 3x and 4 aren't like terms. 8 and x are not like terms. So there's no like terms to deal with this. So step 1 doesn't happen in this problem. Step 2, there's no fractions or decimals. That doesn't happen either. So moving on to step 3, that's where I want to make that distinction between types of things. 3x and x are x terms. 4 and 8 are numerical terms. And it says move x to one side, move the numbers to the other side. It doesn't matter which side you pick, just get them separated between the equal signs. So if I keep my equal sign right where it's at, I could move the x to the left and the 4 to the right. Okay, and when you move things, you change signs. So notice 3x isn't moving, so 3x stays positive. Minus x is moving, so it becomes positive. Negative x moves across the equals, becomes positive x. Positive 8 is not moving, it stays positive 8. Negative 4 is moving across the equal sign, becomes positive 4. You simply make a decision. I want x on this side, I want numbers on that side, and make it happen. Things that move change signs, things that don't move don't change signs. Combine like terms, 3x, and be careful here. Notice in the homework some of you are doing some creative things with this. 3x is being added to x. X is 1x. When we're adding like terms, all we're doing is adding the coefficients. So we have 3x's, we add 1x, we end up with 4x's. Powers don't change, right? It's not 3x squared. It's 3x plus x. So you have 3 objects that are called x. You're adding one more x object. That's a total of 4x objects. That's all we're doing to add like terms. On the right-hand side, 8 plus 4 is 12. 4x equals 12 divided by 4, the coefficient, and x is equal to 3. Again, it divides out exactly right. Now, real quick, I'm going to go back to the original problem over here. 3x minus 4 equals 8 minus x. Re-highlight things. So 3x and negative x are x objects, and negative 4 and 8 are number objects. Suppose in that first decision I made when I said I want x on the left-hand side and I want numbers on the right-hand side, suppose I had decided differently. In other words, suppose instead of doing what I did there, suppose I said, let's move everything x to the right, everything numbers to the left. Let's see what happens. So 3x is going to move, 8 is going to move. Negative 4 and negative x are going to stay. So if I do that, negative 4 is staying where it's at. 8's moving across, it's plus 8 on the right-hand side, it's positive 8. So when I move to the left, it becomes minus 8. Negative x is staying on the right-hand side, not moving, so it stays negative. 3x moves to the right, becomes minus 3x. Okay? And again, this is still negative 1x there. On the left-hand side, these signs are the same, negative 4 and negative 8, so I'm going to add to get 12. 8's bigger, so it's negative. Right-hand side, the signs are the same. 1 plus 3 is 4x, and then 3 is bigger, so it's negative. Divide by negative 4 on both sides. X equals, and notice 12 divided by 4 still equals 3, and 2 negatives makes a positive. We get the same result whichever way we go. So on that step where it says move x to one side, move numbers to the other side, it doesn't matter which side you pick. If you do everything correctly, you'll be fine. All right, so don't get stressed out about, I don't know which side things are supposed to go on. Just pick one and don't change your technique as you go.